Okay, so we're going to start by talking about electrochemistry. And anytime you're converting chemical into electrical energy and vice versa, it's known as electrochemistry. And all electrochemical reactions have one thing in common. They actually transfer electrons between reactants. Okay, so one reactant will give up electrons, one reactant will accept those electrons. If that is not occurring, you do not have an electrochemical reaction. Some of the major categories of chemical reactions automatically transfer electrons. For example, synthesis and decomposition reactions that have substances in elemental form. That means if you've got like pure sodium, pure oxygen, pure calcium, then they will always involve an electron transfer. Let me give you an example. If you have hydrogen combining with oxygen to make water, this is a synthesis reaction. Hydrogen and oxygen are in elemental form. They're pure. And this would automatically be an electrochemical reaction, okay? If I've got some sort of a decomposition reaction, like let's say I've got aluminum chloride, which is decomposing into aluminum and chlorine, that also would be an example of an electrochemical reaction because you have substances in elemental form, okay? Now, synthesis reactions, I'm sorry, not synthesis, single replacement reactions. Let me do this in a different color so it's easier to see. Single replacement reactions and combustion reactions also fall into this category where if we've got something in elemental form present, then an electrochemical reaction will take place. So that means if you've got something like aluminum is combining with zinc chloride. Aluminum is an elemental form. You're going to kick zinc out and you're going to form aluminum chloride. Okay, that would be an example of an electrochemical reaction. If you're talking about a combustion reaction, which would be something like methane, combines with oxygen gas to produce carbon dioxide and water. Oxygen would be in elemental form. This is automatically an electrochemical reaction. Okay. Now, electrochemical reactions are kind of a mouthful, so we kind of abbreviate this to anytime you're talking about a reaction that involves an electron transfer, we tend to call them oxidation-reduction reactions or redox for short. Okay? A major category of chemical reactions that do not involve electron transfer would be double replacement reactions. Okay? And then anytime you do not have electron transfer going on, they tend to call these metathesis reactions. Okay, let's take a look at the next page. Basically, the bulk of this section is on the next page. Okay, thank you. So we're going to spend a little bit of time talking about oxidation numbers. So the way that we keep track of electrons moving between reactants is by looking at oxidation numbers. And oxidation numbers, you will also see them referred to as oxidation states. And these are going to be numbers or charges that we place above the symbol in a chemical formula, and then we track them as we move from left to right throughout the reaction. Okay, so when we come down here to the table, this table outlines all of the rules for oxidation numbers. Unfortunately, you have to memorize these rules. They're not given to you. So the first rule is if you have an atom in elemental form, its oxidation number will be 0. So what we generally do is, here are some examples over here. I've got elemental sodium, oxygen, phosphorus, arsenic, and zinc. You may have a subscript. You may not have a charge. Okay, there's a different rule for things that have charges on the paper. Okay, so what you would do here is you would put your oxidation number above the substance, which would be 0. Okay, rule number 2, monoatomic ions. That means it is a single symbol for an element. It cannot have a subscript, but it must have a charge on the paper. The charge is the same as its oxidation number. So here we have +1 +2, +2, +3, and -1, okay? When you have these ions in chemical formulas, like for transition metals, then those charges on the transition metals in the formulas are the same as their oxidation number, and I'll show you what that looks like when we get there, okay? Third rule, oxygen is -2. There are two exceptions. The first exception is if you have something called peroxide. Peroxide is a polyatomic ion. It's O2 -2, and it has an oxidation number of -1. The only time that you will have peroxide is with a metal. So if this O2 is with a metal, you should be suspicious that it might be peroxide. So that means I would assign the metal its oxidation number first. So generally speaking, all of the metals with assigned charges, like the alkali metals, would be the same oxidation number as their charge, +1. The alkaline earth metals would have an oxidation number of +2, same as its charge. And then aluminum, zinc, and silver, anything with an assigned charge on the periodic table that we have gone over, its oxidation number will be the same, okay? So assign the metal first, then go and assign the O2 that's attached to it, because that will reveal whether it's peroxide or not. The second exception would be OF2. Here, oxygen is a +2, okay? So let me give you an example. Over here, Na2O2. Na is a metal. It's actually an alkali metal. So since you have an O2 attached, you should be suspicious that it might be peroxide. Assign Na a +1. Then you would have to have a -1 on the oxygen because oxidation numbers add up to 0 for neutral compounds, okay? So if I've got two NAs at a +1, I'd have to have two oxygens at a -1. That would be a +2, and a -2, that would be 0. So this is peroxide. OF2 is your exception. You would put a +2 on the oxygen. And then if you were trying to figure out what F would be, it would have to be a -1 because you have two of them already. So a +2 and a -2 would add up to 0. Okay? And generally speaking, because fluorine is a halogen, the halogens generally have oxidation numbers that are the same as their charge, which is a -1. Okay? Let's go on to the fourth rule. Hydrogen has an oxidation number of +1. The exception is if you have a metal attached to hydrogen, its oxidation number is a -1. Okay, so over here, you've got a metal attached to hydrogen. So calcium is an alkaline earth metal, so that means its oxidation number is +2. And then hydrogen would have to be a -1 because it's attached to a metal. Over here I have lithium hydride. Lithium is also a metal. It's an alkali metal, so it's +1. That means hydrogen would have to be a -1. Okay? 5. Oxidation numbers in neutral compounds add up to 0. Okay? So that means when we're looking at something like CuCl or CuCl2, you always have to assign one of them first, the one that you have sort of like the greatest hunch on what it might be. So this is copper 1 and copper 2, agreed? So their oxidation numbers will actually be the same as their charge. And then chlorine is a halogen. Generally, the halogens are -1s. Okay? Rule number 6. Oxidation numbers in polyatomic ions, that means groups of symbols for elements with a charge on it, have to add up to the charge on the polyatomic ion. So this is where you're going to use basic algebra to figure out the unknown. So if you're looking at ClO4 -1, you know that oxygen is a -2. We're going to calculate chlorine. You always know oxygen and hydrogen. Okay, so you generally assign those first, and then you go and you calculate the other one. So chlorine plus, I have 4 oxygens at a -2, add up to this charge on the polyatomic ion, which is a -1. So this would be Cl -8 equals a -1. Chlorine would be a positive 7. Rule number 7, always assign the more electronegative element a negative oxidation number. Okay, so let's go over the trend for electronegativity. If this is a periodic table, the trend for electronegativity is it increases in this direction. Okay, so that's why, generally speaking, the halogens are -1, because they generally are going to be the more electronegative element in a compound that you're looking at. So over here for PF5, fluorine is more electronegative than phosphorus. Assign fluorine, then figure out P. If this is a -5 on the right side, that means P would have to be a +5. Okay? Last rule. Rule number 8. If you have a compound or an ion that has more than 2 elements in it, the element furthest to the right will have its most common oxidation number, meaning its most common charge. So when you're looking at SCN -1, N is furthest to the right, assign it its usual charge, which is a -3. Then go and figure out the other two from there. I have sulfur and carbon left. Which one is more electronegative, carbon or sulfur? Sulfur. So you would assign sulfur its common charge, which is a -2. Then you would use basic algebra to calculate carbon. So I have a -2 on sulfur plus carbon plus a -3 on nitrogen. This adds up to this -1 charge on the polyatomic ion. -2 and -3 is -5. Put the -5 on the other side. Carbon is going to end up being a +4. Let's turn the page. It takes practice getting this down, okay? So what I want you to do is take a look at the practice problems that are on the next page. And I want you to work on those with the person sitting next to you, and let's see what you guys come up with. Okay. On number 8, there are 2 ways to figure out what the oxidation number would be on S, because this is a polyatomic ion, it's sulfate. You can either take the sulfate out of that equation and go, okay, I've got a sulfur, 4 oxygens at a -2, and the charge on sulfate traditionally is a -2 because it looks like this, right? So then what you could do is figure out what sulfur is from there, +6. Your other option is to use the entire equation. So if you do that, you have 2 aluminums at a +3 plus 3 sulfurs, because you distributed this 3 to sulfur, and then distribute the 3 to the 4 on the oxygen. So you've got 12 oxygen at a -2. That all adds up to 0 because it's a neutral compound. And then from there, it's 6 plus 3s minus 24. So what's 6 minus 24? -18. Same thing. Does that make sense? So you can use either one. Okay, so that's oxidation numbers, yes.
Just clarifying.
Yeah.
So for metals with assigned charges, we can just put the charge.
Exactly. Okay, so why don't you guys go on break?